Hello everyone. Good morning. I am Santhosh Kumar Ravindran, delivery lead at Adroitts. Thank you for joining my Lightning Talks presentation. I help Adroitts customers by bringing them success by adopting innovative IT technologies for solving typical IT problems. In today's presentation, I am happy to share my team's effort in utilizing Presto engine for solving the batch data processing problem for one of our clients. And I want to share the agenda, which we'll be going over today. First, I will introduce about my company, Adroitts, and what we do, mission and vision statement. And then we will go over the problem which we had, the challenge which we faced, and why we chose Presto. And in Presto, we have chose AWS Athena in the first instance, and what are all the benefits and what are all the disadvantages we have faced with Athena, and why we went to Ahana, and now we are happy with Ahana. About Adroitts. Yeah, we are Adroitts. We are an independent software vendor. We help customers for their success by adopting and researching the latest innovative IT technologies to solve their typical IT challenges. We have our vision of helping small and medium businesses by being a bridge, by spreading the wisdom of latest technologies to solve their problems in a cost-effective and reliable manner. Our mission is to keep our customer success as first by building safe, reliable, cost-effective, and secure products. And also we have a personalized approach for approaching customers to solve their problems in an innovative manner. Coming to the problem that we had by which we used Presto, the problem is for one of our customers, we want to do a linking algorithm where we want to match customers' transactions with the customer's profile information in the data lake. We host the data files, the customer's profile information, which is 32 GB, and also the customer's transactional information, which can vary from 1 MB to 12 GB in AWS S3. So we host these files in S3, and being a data lake, we want to see what service can help us to query and to make this linking algorithm process fast effective. As we used multiple steps to find the matches, and also we have used some fuzzy logic, which will help us to find additional matches. We utilized Presto being used at Facebook and Uber for big data query challenges. We felt relevant and we have utilized Presto for the case. And as part of this process, we generate three outputs like matched output, unmatched, and the summary. So after we have decided Presto as our compute engine to do the linking process, first we chose AWS Athena. Being serverless and being cost effective, you have to just pay for how much you use, and you build like for the data scanned up to 1 terabyte will be billed just $5. And it's easy to use, like simple, you use glue catalog to query S3 files as is, and it's also managed by AWS. So no infrastructure management by us. Everything is taken care by AWS. And we just captured few use cases which were relevant and which were useful and which made the choice of AWS Athena as a right choice. The first use case where we ran a 1 GB transaction file with the static 32 GB's profile information, and it ran in just less than 5 minutes. And then on a bigger use case where we just chose a bigger transactional file of 12 GB, and when we ran the linking process, it just took around 25 minutes. So everything was good until the point when we were testing in a solo mode where we submit the jobs in a solo mode, like a serialized manner. The problem came when we started utilizing the AWS Athena service for submitting concurrent jobs. So as you see in the bottom part, we tested with 4 invocations with different transactional file sizes with 1 GB, 6 GB, 13 GB, and 15 GB. So when we submitted these jobs in parallel, we saw the results took little more time when compared with the solo mode. And even for a bigger size, for the invocation 4 in case, so we had 15 GB of data. It took more than an hour and few queries failed and stalled, and we had no control, like why it's failing, what was the hard limit we have to target on. So there was no visibility or no transparency on the AWS Athena service, so that we can decide on our performance benchmark that this is the limit and this we have to go by this limit. And also, in addition, the queries get queued up behind the scenes, so we absolutely have no control on the concurrent execution. With these problems, we defined a few factors like what are all our requirements for the next Presto engine service, which is needed to solve all these problems which we are currently facing. So we do not want any stalling or failing queries, and we wanted more control on the deployment, on the cluster usage, and we want to make it scalable on demand. For example, at some point of time where we get a lot of jobs, we wanted to make sure we were able to make some scalability decisions at that point, and to scale up the clusters during that point, utilize them. After the engine has completed, we can scale down to reduce, so that we can get a predictable performance and support and a manageable GUI interface for easier administration. With all these factors on our research, we found Ahana Cloud to be our perfect solution, which helped us scale on demand in a dynamic manner. And also it has a subscription as pay as you go, where you will be billed only for the duration you use their service. And now I want to discuss how Ahana Cloud fared well compared to Athena. So as you see the performance benchmark results on the use case 1 and 2, which we have repeated for AWS Athena, the use case 1 for the same 1 GB of file, we provisioned a Ahana Cloud cluster in AWS with 5 worker nodes of node type R5 2x large. And it just took 3 minutes for getting the results back, in contrast of less than 5 minutes with Athena. Similarly, when tested for a bigger file in a 12 GB customer transaction file, we got the results back in 16 minutes, in contrast to 25 minutes with AWS Athena. Also, I want to bring you to your attention that the billing model of Athena and Ahana are a little different. Being AWS Athena as serverless and completely managed by AWS, they have a model of billing you based on usage, like how much data you have scanned in S3 for each query. But on Ahana Cloud, since you provision the clusters, you pay for the clusters which you provision. So it is based on the cluster size. So we tested the cost for 8 complex queries, and when we tried to run them in concurrent manner, as we saw the concurrent issues that popped up, and the results took long time, and the more the time it took and the more the data it scanned, we had around $16 for the 8 complex queries being fired against AWS Athena. But for Ahana, since we have provisioned around 24 worker nodes, it was able to fairly quickly finish the jobs which have been submitted, and it costed just around $9. And also, we wanted to follow a few next steps where we can optimize this configuration and see like where we can improve the execution speed and reduce the latency. Like we wanted to check on the optimizations like on the query, like whether we can do some partitioning or filtering or joining, data optimizations like using Parquet format or versus ORC format, and partitioning the files so that the engine can run them in a multi-threaded manner. And also we wanted to do a performance benchmark to measure like what is the optimal concurrency limit that can be handled for a given set of workloads. So we are really happy with Ahana Cloud being able to solve our customers' IT challenge in an effective and performant manner. Hope you guys enjoyed the presentation. Hope you guys will definitely use Presto in your organization also. Thank you so much.